We're asking a lot of women these days. Just as our careers start to gain momentum, we're slapped with these fear-mongering headlines. If we struggle to get pregnant, our options include peeing on a stick every day or jabbing ourselves with IVF needles, if our insurer employee covers it, that is. Then, the pressure to return to work means that the postpartum period can become crippling, followed by menopause, with resourcing for this period so poor that up to 25% of women consider exiting the workforce just as they've started to make their peak earning capacity. Now, this doesn't seem very fair to me. Somewhere along the way, we realized that the first step in clawing back some autonomy is optimizing our health. Cue consumer health tech. Now, this seems great in theory until we realize that the majority of data sets that wearables are trained upon are male-dominated, and female sex differences, particularly hormonal differences, make significant differences physiologically. This is what I refer to as the optimization problem. The tools that have been designed to make our lives easier have not been designed with the female body in mind. So, I came to Yale to make one that is. I've paired up with the brilliant biomedical engineer Emily Duchesne, and together we're making a tool that finally enables women to optimize their choices. Step up to your sink every day and let me introduce you to Fern, a smart toothbrush that analyzes biomarkers in your saliva to provide specific, dynamic, and personalized insights to the female body. Not always on, but always part of your morning routine. With AI-enabled predictive algorithms, we now have the unique opportunity to communicate the personalized choice matrix every woman operates within. Do or don't get pregnant. Track the hormonal fluctuations that shape pregnancy, postpartum, perimenopause, and polycystic ovary syndrome. Plan sleep, diet, and exercise regimes to maximize performance in the gym, workplace, and bedroom. Wake up every morning and brush your teeth knowing you have the data to finally take back control. So how does this actually work? Thanks to Emily's incredible brilliance, we're using a novel technique that combines membrane technology and biosensors. By using a membrane that's specific to the hormones that we're sensing, we're excluding excipients in saliva, ensuring that a pure sample can reach our sensor. The sensor then analyzes concentrations within the saliva and transmits this data to our smart application. This enables women to track longitudinal trends as well as daily measurements, all from brushing their teeth. So why saliva? Well, unlike urine and blood, saliva can be collected non-invasively and as a toothbrush in a frictionless way. We've actually been measuring hormones in saliva since 1983. And both the literature and our own research have confirmed a strong correlation between blood, the gold standard, and saliva. So what do we need to get going? Well, we're currently soliciting angel investment for people who are passionate about consumer products that empower, made by women, for women. If you're interested, we'd love to hear from you. Fern is more than just a toothbrush. It's a personalized decision engine that enables women to reduce their trade-offs. Women are 50% of the population, but 100% of the life force. It's about time we made things easier. forEVA, for everyone. Thank you.
Thank you. Great job. Questions?
Hi, thank you for that presentation. I'm curious about how much saliva is necessary to get to an accurate reading for these hormones, and what has been the comparison between the accuracy of measuring it saliva compared to serum?
Great question. So in the samples that we've taken, we can collect an accurate sample within 2 minutes, which conveniently actually aligns with industry standards. So you're supposed to brush your teeth for 2 minutes. That's important because it means that we can actually tackle 2 birds with 1 stone, oral hygiene and biosensing. We're going to build some kind of timer buzzer into the brush so that women know when they've hit that 2 minutes, that we can collect a large enough sample, but also ensure that they're meeting the industry standards for dental hygiene. Now, compared to serum, Saliva measures the free component of the hormone. What does that mean? So, serum captures both the hormone that is bound and what is freely circulating. Saliva is just the free component. Now, that's actually really interesting for a couple of reasons. The free component of the hormone is that which can be uptaken by any tissue within the body, and is also the only portion of a hormone that can cross the blood-brain barrier. So when we look at how hormones are neurotransmitter, hormonal modulators, capturing the free component is very important. At the same time, there are certain disease conditions that are modulated by the level of free hormone component. So for example, polycystic ovary syndrome. In a serum-saliva correlation, it was found that women with PCOS had the same serum levels as women without PCOS, but the level of freely circulating estrogen was higher, up to 2 times higher in women with PCOS. This actually is a rare opportunity to use the difference between free versus serum total bound hormone to look at new disease metrics and surface diseases that are difficult to obtain within the population.
Thank you very much. I get your dream and I share it. Longitudinal data, very, very important. What's the method, Eliza, on the platform?
So we're using aptamers and antibodies within a reusable sensor. So we're doing all of our initial testing with ELISA to validate, but the goal is to use aptamer technology with an enzyme cleaving agent to make